We're going to discuss quadratic equations, solving them, and then develop what we call the quadratic formula, where that comes from. But before we do, I want to kind of take a look at a few kind of shortcuts in solving quadratic equations and some of the reasoning or the theory behind what we can do. First of all, if we have an equation like x squared equals 9, what's probably the quickest, easiest way to think about solving this? Okay, square root both sides, and we get x equals square root of 9. Now, one thing we've got to be careful with here is not just square root of 9, but we can say it's both the positive and negative 3. And we can come back up here and say, well, 3 squared is 9, but also negative 3, the square of negative 3 is 9. So we do need that plus or minus in there when we do the square root. Why, mathematically, where does that plus or minus come from? Well, let's take a look at this in a little different direction. The process, like we said, we can square root both sides of the equation, but what is the square root of x squared? This is kind of the details that we tend to forget about or not even see as instructors are explaining this. Square root of x squared is, well, actually a couple different values. It depends on what x is. If x is, say, 3, then square root of x squared is 3, which is x. So in that case, square root of x squared is x. What if x equals negative 3? Does square root of x squared equal x this time? Well, technically, square root of x squared, if x is negative 3, the answer turns out to be 3. That's not x. X is negative 3. Well, it happens to be the opposite of the x value. Or in, well, that notation kind of looks strange, but that little dashed line is not a negative in this case, but means the opposite of x. So let's see what this means then as we look at it through this idea. The square root of x squared, we're going to have two possible outputs for this. One is what we would expect. That's going to be x, but that's true only if x is greater than or equal to 0. Square root of 0 squared is 0. Square root of 1 squared is 1. Square root of 3 squared, as we showed, is 3. So the square root does cancel the square, and we're left with just the x value. But if x is negative, we have to say we end up with the opposite of x. Square root of negative 3 squared is not negative 3, it's the opposite of negative 3. Square root of negative 5 squared is not negative 5, but it's the opposite of negative 5. It'd be positive 5. So this, well, this is actually a definition of another function, which happens to be the absolute value. Square root of x squared and the absolute value of x are defined exactly the same way. Completely different operations, but they're defined, they have the exact same results. So, when we solve this equation x squared equals 9, when we take the square root of both sides, square root of 9 is 3, but the square root of x squared we have to think of as the absolute value of x, which then opens up the possibility of both positive and negative 3 for the solution. So instead of going through that entire process all the time, we usually just say the shortcut of this, we'll throw the plus or minus in there and then the square root as well. This comes from this process right here, and we end up with x is both positive 3 and negative 3. Okay? Questions? Okay, next equation. Well, in this form, one thing we could do is use the square root principle, take the square root of both sides and solve it. Now, some of us may look at this and say, well, we need to multiply out the square and then set the equation equal to 0 and solve it that way. That works too, but what we can do with taking the square root of both sides, let's look at it in this manner. Now, again, technically, the square root of the square, the results will be the absolute value, which, oops, I guess we need to square root both sides, which the right side then we can say it's both positive and negative square root of 5, and we have the x minus 4. Well, to solve that for x then, we just need to add 4 to both sides, and x is going to be 4 plus or minus square root of 5. Well, that's two separate answers, 4 plus square root of 5 and 4 minus square root of 5. But for simplicity's sake, I would accept this form. Just recognize that is two different equations. Now, this is actually the exact same equation as x squared minus 8x plus 11 equals 0. And what most of us would do if we see this, we're going to use the quadratic formula. Okay. Now, we could turn it into this form, and in some cases, if I recognize the easiness of what I say completing the square, then I may look at it to turn it into this. To complete the square here, we're going to turn this equation back into this part, and what we do is get the x squared and the x term on the same side, and we can subtract 11 from both sides. Well, let's take a look at what we can do with x squared minus 8x. Can we add some number to make that a perfect square. I'm sure most, if not all of you, have seen at least a little bit of completing the square. Maybe a little fuzzy right now, but we'll work through that. What we need to look at is we take 1/2 of the coefficient of the x part, and then we square that. Well, we get -4 squared, which would be 16. So when we're looking at x squared minus 8x plus something, and the equation says that's going to equal -11, well, whatever we add to one side of the equation, we have to add the same thing to the other. So we're going to add the 16. And guess what? This factors into x minus 4 quantity squared, and the other side gives us 5, and we now have this exact form right there. So we could finish it by using the square root property. Now, what I said earlier about seeing it in this form, we would probably go directly to the quadratic formula. Where does the quadratic formula come from? Well, it's by solving the general form of a quadratic equation, just like we did this right here. We have to go through completing the square process, and then take the square root of both sides, and then simplify algebraically. That's how we complete, or how we, I guess you could call it, prove the quadratic formula. Now, in this case, we had a very easy form of the equation when we go through completing the square. Anytime we complete the square, the x squared part must have 1 as the coefficient. If it's not, then we can't go through this process. Well, let's take a look at something that, an equation that does not have 1 as the coefficient. We'll just look at it this way. Well, in completing the square, we only have to worry about the x squared and the x. So very first thing, we'd subtract 6 from both sides. And then, well, then it gets a little complicated, you might say. To get 1 as the coefficient of x squared, we have to, well, we could either think divide by 2 on both sides or multiply by 1/2. Whichever the case may be, probably easiest to see this way, we end up with x squared minus 5/2 x equals -3. So we go through completing the square. This case is a little harder to see, but we take 1/2 of the coefficient of x, and then we're going to square that quantity. Let's see, we get, now this step a lot of times we just do in our head, but I'm going to write it down here to show you what result this will give us. -5/4, and then we square that, which would give us what? 25/16. So we're going to add 25/16 to both sides of this equation. And going through completing the square with fractions, it gets really difficult at this point, unless you know the shortcut for completing the square. This will factor into what? that will actually factor into x plus whatever this is before we square it. So in this case, plus a negative, we normally just say x minus 5/4. And then this side, we have a little bit of work to do. -3, turn it into a fraction with 16 as the denominator. That is, what, -3 times 16? Okay, so -48 plus 25. Do some calculations up here. We'll end up with -23 over 16. Okay. So in our completing the square process, this equation can be written this way, and then square root both sides. We'll have plus or minus, and then, well, we end up with a square root of a negative, so end up with the I complex number. We can add the 5/4 to both sides, plus or minus, and simplifying that square root, well, as much as we can. The denominator, at least, we can write square root of 16, which is 4, and we end up with this. So using the quadratic formula, we would have ended up with this form. So we get the same answer, little different approach, but this process right here is what we're going to use to prove the quadratic formula. Okay? Now, to prove it, we're going to use letters to represent the coefficients and the constant. Solving this, we're going to go through exactly the same procedure we did with our previous example. Looks a little more difficult with the letters, but exact same procedure. First of all, subtract c from both sides. Then we divided by the coefficient of x squared. So divide by a. And we get x squared plus coefficient of x is b over a. And then the other side would be negative, or the opposite of c over a. Okay. Then what? Now we're ready to complete the square. Take 1/2 of our coefficient of x and square it. Whoops, I wasn't wanting to do that just yet. We'd have b over 2a quantity squared, which then is b squared over 4a. So our x squared plus b over a x plus b squared over 4a, over 4a equals negative c over a plus b squared over 4a.
Would the a still be squared?
Yes, a would be squared. Good catch. Thank you. Okay. I would have caught that eventually, but I'd have probably been going, why did that not work out? Okay, so now, what's that factor into? said earlier, it's always going to factor into x plus whatever we have here before we square it. So x plus b over 2a, quantity squared, and if you'd want, you can go ahead and multiply that out in terms of your a, b, and c, or I guess a and b in this case, and you should get this right here. Now the other side, we have negative c over a plus b squared over 4a squared, and that one, to fit the form of our equation, our quadratic formula, we're going to want to go ahead and combine that as a single fraction. And like a lot of places where we have a negative and then adding a positive value, a lot of times the form will flip that around where we have the positive first and then minus the other one rather than a negative plus the positive value. So I'm going to go ahead and rewrite that. And as we do that, we're going to need 4a squared to be our denominator, common denominator for those fractions. What shall we do for c over a to make that 4a squared in the denominator?
Times it by 4a.
Okay. And so we'll have the 4a squared in the denominator. Get b squared over 4a squared minus, now c times 4a, again the typical way to write that, reorder it. Anytime we're dealing with letters, it's usually alphabetically. And then over 4a squared. So combine this side as one fraction now. We get the b squared minus 4ac all over 4a squared. And next step, move to the top of the next page. We've got our perfect square equals what was it? Okay. B squared minus 4ac was all over 4a squared. And the procedure then, square root both sides, which technically this would be the absolute value of that quantity, but we'll go ahead and do the shortcut of just taking plus or minus the square root of this whole thing. Subtract this from both sides. Plus or minus, simplify the fraction. Square root of 4a squared. And we do have 2a as the denominator in both parts. We see now where the quadratic formula comes from. Questions? Now, as we go through calculus this semester, we're going to run into a lot of problems where we're solving quadratic equations. Some may be as simple as just factor. Some may be as simple as just take the square root of both sides. But when you do that, remember, that shortcut of plus or minus. Some you may recognize if you're comfortable enough with completing the square, you may want to do completing the square rather than just plugging it in the quadratic formula. But many times you'll be using the quadratic formula because that's the easiest way. But definitely you've got to know this, know how to use it, and be careful because there's a lot of operations in there, lots of opportunities for little mistakes, especially for getting those little dashed lines we call negatives. If B is a negative value or if A is a negative value, it can cause some problems. But lots and lots of points through the semester we're going to be solving quadratic equations.